Inside a cave in the Oregon high desert, researchers found human waste old enough to break a rule American archaeology had defended for most of a century. The official timeline said it should not exist. For decades, anyone who claimed to have found something older was quietly, professionally dismissed, their career sometimes ending over it. Then a team of scientists ran test after test on material nobody wanted to believe, and the number that came back should have been impossible. By the end of this, you are going to understand exactly what was found in that cave, why the field fought so hard against it, and why the fight itself tells you something uncomfortable about how carefully guarded scientific consensus actually is. Picture the Summer Lake Basin in south central Oregon, the way it would have looked to the first people who ever sheltered there, because the landscape still carries the memory of what it used to be. Today it is high desert, sagebrush stretching toward distant rimrock, the air thin and dry, the kind of terrain that looks empty until you notice the layers of geological history written into the exposed rock faces. But during the Pleistocene, the tail end of the last ice age, this basin held a vast pluvial lake called Lake Chewaucan, its waters rising and falling across cycles of greater and lesser rainfall, carving wave-cut shorelines into the surrounding hillsides as it moved. Along the highest of those ancient shorelines sits a series of 8 caves, westward-facing rock shelters worn out of the cliffside by water that has not touched them in thousands of years. Today, they are known simply as the Paisley Caves, named for the small nearby town, and they do not look, at first glance, like a site capable of overturning a century of settled science. Archaeologists have known these caves existed for a very long time. A University of Oregon researcher named Luther Cressman first identified their significance back in the 1930s, decades before anyone had the analytical tools to actually test what was buried inside them. Standing at the mouth of one of these shelters today, looking out over the flat expanse of the old lake bed, it is easy to understand why early explorers of the region would have noted them without immediately grasping their significance. They are not dramatic caverns stretching deep into a mountainside. They are shallow, wave-cut hollows, more shelter than cavern, the kind of place a small group of travelers might use for a few nights of protection from wind and weather rather than a permanent settlement. That modesty is part of what makes the eventual scientific weight of the site so striking. Nothing about the caves themselves announces their importance. Whatever significance they hold had to be extracted patiently from the layers of silt and sediment accumulated on their floors over thousands of years. For most of the 20th century, the caves sat as a known but secondary site, noted in the literature. Occasionally excavated, never treated as central to the biggest question in American archaeology. When, exactly, did humans first arrive in the Western Hemisphere? That question sounds almost quaint, stated so plainly, the kind of thing you would expect to have been settled generations ago. It was not settled. It was, for most of the past 100 years, one of the most contested and career-defining debates in the entire discipline, and the caves in this quiet Oregon basin would eventually sit at the center of blowing that debate wide open. Here's the detail that should already feel slightly wrong, even before we get to the science. Something as ordinary, as biologically unglamorous, as ancient human waste, preserved by dry cave conditions for thousands of years, would end up being one of the most scientifically valuable and fiercely contested categories of physical evidence in the entire field of early American archaeology. Not a spear point, not a burial, not a monumental structure, a coprolite, the technical term for fossilized feces, sitting quietly in a cave in Oregon, waiting to become the exact kind of evidence a century of established consensus had no comfortable place to put. Here's the story that held for most of the 20th century, and it held because the field had genuinely compelling reasons to believe it. Since the early 20th century, American archaeology operated under what became known as the Clovis First model, named after a distinctive style of stone spear point first identified near Clovis, New Mexico in the 1930s. These points, broad, elegant, fluted at the base for hafting onto a spear shaft, showed up at sites across North America dated to roughly 11,500 radiocarbon years before present. And for decades, no credible evidence of human presence in the Americas predating those points ever managed to survive rigorous scientific scrutiny. The model that emerged from this pattern was clean and internally consistent. Humans crossed from Siberia into Alaska via the Bering Land Bridge sometime after the last glacial maximum, waited for melting ice sheets to open an interior corridor south through what is now Canada, and then spread rapidly across 2 entire continents, developing the Clovis Toolkit as the founding technological signature of the very first Americans. Generations of students learned this timeline as settled fact, the same way they learned the dates of major wars or the names of ancient civilizations, with no hint that the foundation underneath it was ever seriously in question. This was not a story defended out of stubbornness. It was defended because it was, for a very long time, the best supported explanation available, built on a genuinely impressive and consistent body of physical evidence. Clovis points had been found at dozens of well-documented sites across the continent, frequently in direct association with the bones of now extinct megafauna like mammoths and ancient bison, giving researchers a clear, repeatable picture of who these people were and how they lived. Every time an archaeologist claimed to have found something older, credible scientific scrutiny consistently found reasons to doubt it. Contaminated samples, disturbed stratigraphy, misidentified materials, dating errors introduced by the primitive radiocarbon techniques of the mid-20th century. Given how frequently earlier pre-Clovis claims had collapsed under closer examination, treating any new claim with serious skepticism was not closed-mindedness. It was the field doing exactly what rigorous science is supposed to do, refusing to overturn a well-supported model until the evidence against it became too strong to reasonably explain away. There is also a deeper reason this model felt so satisfying to generations of researchers and the public alike, beyond the raw physical evidence. It offered a clean, almost elegant narrative arc, a single migration event, a single founding technology, a single moment when the Americas went from empty of humans to populated by them. Textbooks could teach it in a paragraph. Museum exhibits could illustrate it with a single map and a single arrow sweeping down from the Bering Strait. That narrative simplicity was not itself evidence of truth, but it made the Clovis first model unusually resistant to revision because any challenger was not just fighting against a body of physical data. They were fighting against a story that had become deeply embedded in how the entire field, and much of the interested public, understood the deep human past. And there was a real professional cost embedded in that caution, too, which made the skepticism even more understandable. Archaeologists who published claims of pre-Clovis sites in earlier decades had, in a number of well-known cases, seen those claims eventually fall apart under scrutiny, sometimes publicly and painfully. That history left the discipline with a kind of institutional memory, a collective wariness about pre-Clovis claims that was not irrational paranoia, but the scar tissue of a field that had been burned before. Anyone bringing forward new evidence for human presence in the Americas older than Clovis knew, going in, exactly how high the bar of proof was going to be set, and that they would need evidence strong enough to survive attacks from researchers, who had every professional incentive and every historical justification to try to tear it apart. Here's where it starts to get stranger, because the caves that would eventually challenge this consensus had already been sitting there, quietly, for decades, before anyone treated them as the site capable of doing it. In the early 2000s, senior archaeologist Dennis L. Jenkins of the University of Oregon's Museum of Natural and Cultural History returned to the Paisley Caves for a fresh round of excavation, decades after Cressman's initial identification of the site. What Jenkins and his team found were coprolites, dozens of them eventually, preserved in the dry, stable conditions of the cave sediment layers, alongside animal bones and sagebrush twigs that could be radiocarbon dated with precision. Radiocarbon dating one of these human coprolites, along with associated camel and mountain sheep bones, recovered from the same stratigraphic layer, produced an age of roughly 14,300 radiocarbon years, adjusted to approximately 14,400 calendar years. Read that number again against the Clovis first timeline. Clovis technology appears in the archaeological record at roughly 11,500 radiocarbon years ago. This material predated that by nearly 3,000 years. Now look closer, because the number alone was never going to be enough to move a field this cautious. Coprolites are not spear points. They cannot obviously visually be identified as human simply by looking at them, and that ambiguity became the first serious crack skeptics pushed on immediately, and given the field's history, entirely reasonably. Could these actually be from a large carnivore rather than a human? Could the DNA identified inside them have leached in later, carried downward through the cave's layered sediment by water or rodent urine, contaminating older material, with genetic evidence from a much more recent human presence at the site? These were not bad faith objections. They were exactly the kind of rigorous, structurally sound challenges a claim this consequential needed to survive. And for a period, they represented a genuine, open, unresolved threat to the entire finding. The stakes of that specific objection were higher than they might first appear, because cave sediment is a genuinely treacherous environment for this kind of dating. Unlike an open archaeological site, where stratigraphic layers tend to remain relatively undisturbed, caves are dynamic systems, subject to water seepage, rodent burrowing, and the kind of slow vertical mixing that can, over thousands of years, blur the boundary between what belongs to one occupation layer and what has drifted down from a much later one. A skeptic did not need to accuse anyone of fraud or carelessness to raise a legitimate doubt here. They simply needed to point out that caves, as a category of site, have a well-documented history of producing exactly this kind of contamination problem, and that Paisley Caves had given no obvious reason on its own to assume it was somehow immune. Here's where it gets stranger still. When Jenkins' team went back to specifically test the contamination hypothesis, they found something that complicated the picture in an unexpected direction, rather than simply resolving it. In one non-human coprolite, dated by two different methods, the macrofossil material inside it and its water-soluble extract produced two different ages, roughly 800 radiocarbon years apart, a result that demonstrated some material genuinely could move vertically through the cave's sediment layers over time. That finding should have been terrible news for the pre-Clovis claim. Instead, when researchers applied the exact same dual dating method specifically to the three coprolites identified as human, the two independent dates on each sample agreed with each other closely. The contamination pathway that skeptics had proposed, the one that could plausibly explain away the entire pre-Clovis finding, demonstrably existed in this cave's sediment, and it demonstrably was not what had happened to the human sample specifically. Now consider what happened next, because the field's response was not to quietly accept this and move on. Jenkins, aware of exactly how much institutional skepticism a claim like this would face, did something unusual. In the fall of 2009, he invited skeptics directly to the site itself, hosting what has been described as an archaeological summit, bringing doubters face to face with the excavation, the stratigraphy, and the raw data in person rather than only through published papers. Several previously unconvinced researchers left that gathering persuaded. Others remained unconvinced, and their formal published objections, including direct scientific rebuttals from researchers who specifically challenged the DNA contamination question, continued appearing in the literature for years afterward. This was not a story of one dramatic discovery ending an argument. It was the beginning of a genuinely adversarial, years-long scientific process, playing out entirely in public, in peer-reviewed journals, between researchers with real professional stakes on both sides. So here is the question that had to hang over this site for the following decade. It was not, on its own, the kind of ironclad, method-independent proof that could settle a debate this consequential and this contested. Something else was going to be needed, a completely different analytical approach that did not rely on DNA at all, before this finding could move from compelling but disputed to something closer to established fact. The investigation that finally addressed this gap did not happen quickly, and it did not happen through a single dramatic breakthrough. It happened because a group of researchers recognized correctly that the entire DNA contamination argument, however carefully they tried to control for it, was never going to fully satisfy skeptics as long as DNA remained the primary line of evidence. What the field actually needed was a second independent method, one that could confirm or deny the human origin of these coprolites using an entirely different kind of chemical signature immune to the specific contamination pathway that had already been demonstrated in this cave's sediment. That method is called fecal lipid biomarker analysis, and it works on a completely different principle than DNA sequencing. Rather than looking for fragments of genetic code, researchers examined the specific fats, sterols, and related organic compounds preserved within ancient fecal material. Different animals produce measurably different ratios and combinations of these lipid biomarkers based on their diet, digestive physiology, and metabolism, meaning a sample's lipid profile can, in principle, distinguish human waste from that of other omnivorous or carnivorous species without requiring any surviving DNA at all. Crucially, these lipid compounds behave very differently in soil and sediment than DNA does. They are less prone to the specific kind of vertical leaching through water-soluble pathways that had already been shown to move genetic material through this cave's layered deposits, which made them, at least in theory, a genuinely independent check on the original finding rather than simply a second attempt at the same vulnerable measurement. It helps to understand why this particular gap in the evidence had gone unaddressed for so long. Lipid biomarker analysis is not a new or exotic technique in the broader world of archaeological science. Researchers studying ancient diets, pottery residues, and soil chemistry had used related methods for years in other contexts. What made applying it specifically to the Paisley Caves controversy valuable was not the invention of some brand new technology, but the deliberate decision to point an already existing, well-understood analytical tool at a specific, contested question that DNA analysis alone had never been able to fully resolve. Sometimes the most consequential scientific advances are not new inventions at all. They are old tools, finally aimed with enough patience and precision at exactly the right problem. Picture what this actually required in practice. Because it was neither quick nor glamorous, researchers had to go back into the existing collection of excavated Paisley Caves material, much of it already carefully cataloged and stored from Jenkins's original digs, and select coprolites that had already been dated to the disputed pre-Clovis period through the earlier radiocarbon and DNA work. Each sample then had to undergo a completely separate laboratory process, extracting and analyzing its lipid content using techniques capable of detecting biomarker signatures specific enough to distinguish species. This is meticulous, unglamorous chemistry, the kind of work that produces no dramatic footage and rarely gets covered in mainstream science journalism. Precisely the kind of research that real breakthroughs are usually built on, rather than the kind that makes headlines on its own. The team assembled for this specific investigation, publishing their findings in the journal Science Advances, included researchers working across multiple institutions, among them Jenkins himself, alongside colleagues specializing in organic geochemistry and archaeological science. Their explicit stated goal, laid out plainly in the introduction to their published paper, was to move past the unresolved ambiguity of DNA taphonomy entirely, acknowledging directly that questions about ancient DNA movement through sediment made that earlier line of evidence, on its own, problematic for a claim this significant. Rather than trying to further defend the DNA results against contamination critics, this new investigation set out to answer the underlying question using a method that sidestepped the contamination debate altogether. Here is where the tension actually built, sample by sample, across months of laboratory analysis. Each coprolite tested against its lipid biomarker profile was, in effect, a separate trial of the original hypothesis, an opportunity for the pre-Clovis claim to either gain independent support or collapse under a completely different kind of scientific scrutiny. If the lipid signatures came back ambiguous, or worse, consistent with a non-human species, the entire pre-Clovis interpretation of Paisley Caves, a finding that had already reshaped how dozens of other early American sites were being reconsidered, would have been thrown back into serious doubt. If they came back clearly, unambiguously human, and matched the same samples the original DNA and radiocarbon work had already flagged as pre-Clovis, it would mean two entirely independent lines of chemical evidence, immune to each other's specific weaknesses, had converged on the same conclusion. There was also a quieter, more personal dimension to this specific test that is easy to overlook in a purely technical retelling. Jenkins had spent close to 2 decades of his career tied to this single site, defending its significance against genuine, credentialed opposition, inviting skeptics onto the ground itself rather than only answering them in journals. A negative result from this new lipid analysis would not simply have been a null finding in an abstract sense. It would have specifically undermined nearly 20 years of a working archaeologist's professional life, built on a claim he had staked his reputation on since the early 2000s. That personal stake did not make the test any less rigorous or any less independently conducted. It is the quiet, cumulative moment researchers laid the lipid biomarker results next to the original radiocarbon and DNA findings, and saw the two independent methods land on the same answer. Picture the actual working reality of that convergence, because it looked nothing like a control room with a single dramatic readout. It looked like a research team, spread across multiple institutions, comparing spreadsheets of biomarker ratios against years-old radiocarbon dates and DNA haplogroup assignments, checking sample identification numbers against original field catalogs to make absolutely certain they were comparing results from the exact same physical specimens rather than merely similar ones. When that comparison was complete, the paper's stated conclusion was direct and carefully worded, the kind of careful, hedge-appropriate language real scientific papers use even when the underlying finding is significant. The fecal lipid biomarker analysis demonstrated unequivocally that 3 coprolites already dated to the pre-Clovis period were human in origin, providing independent confirmation that did not rely on the DNA evidence skeptics had spent over a decade contesting. Sit with what that convergence actually means, because it is stranger and more scientifically meaningful than a single dramatic discovery would have been. 2 entirely different analytical methods, one reading genetic code, the other reading fat and sterile chemistry, subject to different contamination risks, different failure modes, different sources of potential error, were run independently against the same disputed material and arrived at the same conclusion. That is not the kind of result a single flawed measurement or a single contaminated sample could produce by accident. It is the specific kind of convergence that, in careful experimental science, is treated as far stronger evidence than either method could provide on its own, precisely because the two techniques do not share the same vulnerabilities. Consider what would have had to be true for this result to be a coincidence rather than a genuine confirmation. It would require the original radiocarbon dating to have been in error in a way that happened to align with a genuinely ancient sediment layer. It would require the DNA identification, despite demonstrated contamination pathways elsewhere in the same cave, to have specifically avoided that contamination in these 3 particular samples. And it would require the completely separate lipid biomarker analysis using a different laboratory, a different chemical signature, and a different research question to have independently landed on the same human identification by chance. Any one of those individually is plausible. All 3 lining up by accident on the same 3 samples stretches coincidence well past what careful scientists are willing to accept, without a much stronger alternative explanation than any critic had yet proposed. Here is the plain language version of what that means, translated out of the careful academic phrasing. Humans really were present at this site in Oregon roughly 14,400 years ago, nearly 3,000 years before Clovis technology appears anywhere in the archaeological record. And this conclusion no longer rests on a single contested line of evidence, vulnerable to a single specific criticism. It rests on independent chemical confirmation using a method skeptics had not yet found a way to seriously challenge. The century-old Clovis first model, defended for entirely reasonable scientific reasons for most of 100 years, did not simply lose an argument to one dramatic new find. It lost an argument to the patient accumulation of multiple independent lines of evidence, gathered over more than a decade, each one surviving scrutiny that earlier pre-Clovis claims throughout the 20th century had consistently failed. What it means for the broader story of how humans first reached the Americas is worth sitting with carefully, because it does not hand you a single, tidy replacement narrative. If people were living in this specific Oregon basin 14,400 years ago, meaningfully predating Clovis, the old, clean story of a single founding culture spreading rapidly across 2 continents after an ice-free corridor opened no longer fits the evidence. Something more complicated was happening in this window of time, possibly multiple waves of migration, possibly a coastal route that let people bypass the interior ice sheets entirely and travel south along the Pacific coastline earlier than the land corridor model ever allowed for. Possibly technological traditions developing somewhat independently in different regions before later intermixing. The field's current, more mainstream reading now considers Clovis one important, but not singularly foundational tradition among what may have been several early overlapping approaches to life in the Americas, rather than the technological point of origin for everyone who came after. This reframing has consequences that extend well past academic debate. For generations, the Clovis first model quietly shaped how the broader public, and even some policy around Indigenous history and land claims, understood the depth and continuity of human presence in the Americas. A model that pushes the earliest confirmed human presence back by nearly 3,000 years does not just rewrite a line in a textbook. It reopens questions about how many distinct early populations may have existed, how they related to one another, and how much of what came later actually traces back to a single point of origin versus a more tangled, multi-threaded beginning that the Clovis first model was never built to accommodate. That raises real, still unresolved questions the field has not settled. Exactly who these earliest Paisley Caves occupants were, in cultural or ethnic terms, remains genuinely unknown, and researchers studying the site have been explicit and careful about not overstating what the mitochondrial haplogroup evidence, consistent with Siberian and Native American populations, can actually tell us about specific group identity. The site has also produced no clearly associated lithic tool assemblage tied directly to these earliest occupants, meaning their technological culture and their precise relationship to the later Clovis tradition that would eventually dominate the continent remains an open question rather than a settled one. And more broadly, if a method as painstaking and independent as lipid biomarker analysis was required to finally quiet a decade of legitimate scientific doubt about one single site, how many other contested early American locations, dismissed decades ago under less rigorous testing standards than exist today, might be sitting in museum storage right now, waiting for exactly this kind of second look? To be fully honest about where this leaves things, because it would undercut everything already said to pretend otherwise. This does not mean every pre-Clovis claim ever proposed throughout the 20th century was secretly correct all along. Most of those earlier claims collapsed under scrutiny for genuinely sound reasons, and the field's decades of caution before accepting Paisley Caves was not obstruction. It was the scientific process functioning exactly as intended, demanding a level of independent, multi-method proof that most earlier claims simply could not provide. What changed at Paisley Caves was not that skepticism turned out to be wrong. It is that, for the first time, a pre-Clovis claim finally produced evidence strong enough and independent enough to survive that skepticism completely intact. There's a bigger lesson worth sitting with before we close this out, and it has nothing to do with coprolites specifically. We tend to imagine scientific consensus as either permanently fixed or constantly collapsing, when the real story is almost always something slower and more disciplined than either extreme. A model held firm for a century, not out of stubbornness, but because it was genuinely the best supported explanation available, and it changed only once. Evidence arrived that could survive every reasonable objection a skeptical field could throw at it. That is not a story about hidden truths being suppressed. It is a story about how difficult and how necessary real evidence has to be before an entire discipline is willing to rewrite its own foundational timeline. It is worth remembering, too, that the people most responsible for finally confirming this finding were not outsiders storming the gates of a closed establishment. Dennis Jenkins spent his entire career inside the institutional structure of American archaeology, at a respected university museum, following the same peer review process, submitting to the same scrutiny as every skeptic who challenged him. The story here is not insiders versus outsiders. It is the scientific process working exactly as intended, slowly, adversarially, and eventually, conclusively, over more than a decade. Run it back one more time. A century-old model, Clovis first, built on genuinely strong evidence and genuinely earned skepticism toward anything that challenged it. A cave in the Oregon high desert, known since the 1930s, but not fully excavated until decades later. Human waste, preserved by dry cave conditions for over 14,000 years, radiocarbon dated to roughly 14,400 years ago, nearly 3,000 years before Clovis. A decade of legitimate, published scientific doubt focused specifically on whether DNA could have leached downward through the cave's layered sediment. And finally, an entirely independent chemical method, fecal lipid biomarker analysis, confirming the human origin of that ancient material without relying on the contested DNA at all. So here's what I want to know from you. If it took over a decade of rigorous adversarial science to finally confirm what one cave in Oregon was quietly holding on to, how many other assumptions about the deep human past are still sitting exactly where Clovis first sat 20 years ago, waiting for someone patient enough to check? Tell me in the comments. I read every single one. And if this one pulled you in, wait until you see what a nearly identical dating dispute turned up at a site on the opposite side of the continent, one most people have never even heard of. That story is next. Go watch it.